so nice to be here. Nice to see you all again. I really appreciate, and I have been waiting for this event. Those of you who doesn't know me, I'm Jonas Birmé. I'm the VP R&D at Eyvind. We are vendor-independent consultants, which means we don't have any reseller agreements. We don't have a platform of our own. But we do build some proof of concepts and prototypes that we do to innovate and drive the industry forward. And our contribution when we do that is that everything we write, the code we write, we release also as open source. We want to contribute, we want to give away what we've done and what we learned so the sort of industry can move forward. That's why we're doing what we do. So I'm going to talk about WebRTC and proof of concept in that area. But we can start by doing a little bit of a recap of WebRTC. WebRTC, to establish a connection, you need to do some handshaking, and you have an offer and answer with something called SDP, which is a session description protocol that contains the necessary information that is needed for the peers to establish a connection. You also send ICE candidates, which means basically simplify IP and ports and the way of actually establishing this connection between the two. And that's what you send. An SDP is like it's a letter with some information that you give to someone, and then you get a letter back, basically. But what is not really standardized is how to send that letter. I mean, one way of doing it could be this proprietary CAML protocol that I've developed. No, just kidding. I was actually inspired by Will Law from 2019, who had camels in his presentation. I thought I also have to have camels in my presentation. And I can confirm it's supremely hard to animate camels in PowerPoint. I wanted to investigate, can we build an end-to-end WebRTC streaming based on a standard protocols between both the ingest side and the playback side? And I often get a question, okay, how are you solving this with DRM, copy protection? How do you solve this with H.264, 10-bit? How do you solve this, blah, blah? Well, the intention with this proof of concept was not to solve all this area. The intention with this proof of concept was to see, is there a way that we can separate the concerns? Is there a way where you can work on the ingest side, encoding side, independently from the playback side, independently from the distribution side? Because I think it's very hard. I wouldn't maybe say impossible. It's very difficult for one to solve everything. And I think what's something we've learned in this industry is that if you separate the concerns, you can focus on doing the distribution really, really well on a large scale. You focus on that. But you cannot do that unless there is a standard in and a standard out. So I think that's why it's very important. And I'm really happy and I appreciate the effort that's been done in this area to move this forward. Also on the client device side, I know the playback side is probably the hardest side, but looking at the device support today, there isn't that many devices that have some inbuilt real-time protocol, except WebRTC. So it's not a bad choice in that way as well.